is the auditory system part 2. So we have to explain now the function of inner hair cells. The function of inner hair cells, they transform mechanical vibrations into electric nerve signals. The mechanical vibrations from the basilar membrane to electrical nerve signals. And this is very shortly described. We have some stereocilia here. You can see up the inner hair cells here. And so when they are moved to the right, the stereocilia, then there will hair cells will the hair cell will be depolarized, and that means that some so-called neurotransmitters will be released, and then some activity in the nerve cells in the form of spikes, electric signals. So, and when the stereocilia is just upright, there is no action. The neurotransmitters are those small, you can say, electrochemical substance. So the basilar membrane displacement towards scalar media. Scalar media is here. It's towards scalar media here. Then if the bends right, the stereocilia, there will be some fluid, the potassium enter the cells, into the cells. And that means that a so-called depolarization of the cell, and this will release those so-called neurotransmitters, and then spikes are generated in the nerve cells, auditory nerve. Function of the inner hair cells. That is transformation from mechanical to intracellular potentials. And low frequencies will make a fine structure. Low frequencies makes a fine structure, and the spikes and the neurons are able to catch those things. But high frequencies, we are talking about envelopes. The temporal frequencies, the fine structure is too, the individual frequencies are too high, so the neurons are working with high frequencies or envelopes. No envelopes, as I understand it. Yes. Okay. And what does hair cells do? This their model do. There's a half wave rectification. There's some plus low pass filtering. There's a rectification plus low pass, you can say, filtering at about 1 kilohertz. So it's working with smaller frequencies or envelopes at higher frequencies. Yeah. So what is the purpose of outer hair cells? The outer hair cells amplify basilar membrane motion. The outer hair cells are in touch with sectorial membrane. So the outer hair cells will enforce the movements of the basilar membrane. Outer hair cells amplify basilar membrane motion. That's the end of the story, a complicated story, or the head point of it. Outer hair cells realize a cochlear amplifier, you can say. It's big like that. Yeah. Okay. So we have some tuning curves. That means that tuning curves measure basilar membrane displacement at a fixed location in response to tones with varying frequency and level. Is a fixed location at the basilar membrane, according to in response to tones with different frequency and level. So you can 20 dBs is a sharp spread to the smaller frequencies, and higher level is more is less sharp, and the frequency spread to the low frequency side. Yeah. So tuning curves this measure response to many sinus audios at a fixed locations. At a fixed location. Yeah. Yeah. Different frequencies at a fixed location. Yeah. What does the excitation pattern do? It measures response across places with different center frequencies, with different frequencies. Where the input is one sound. Yeah. So tuning curves is you can say it's at a fixed location at a basilar membrane, and excitation patterns about basilar membrane, about the whole basilar membrane. Yes. Hair cells to auditory nerve connections. Of the 30,000 afferent fibers from it's going to the brain, is connected. 95 are connected to the inner hair cells, and 5 to the outer hair cells. Of the efferent fibers is the long way from the brain to the other way. Is 60% are connected to the inner hair cells, and 40 are directed to the outer hair cells. Inner hair cells are main transducers of information to the higher stages of the auditory system, and outer hair cells modulate responses. It's modulating. Yeah. Okay. So yes, we have some action potentials in a single neuron. Maximum spike rate in a single fiber is limited, so we can hear sounds of about 20,000 hertz, but a single spike is not able to oscillate that fast. Timing of spikes in interspike interval provides information. Remember that we have this inner hair cells. It's a kind of rectifier. So when the stereociliars are bent to the right, there's electric signal spikes activated, or when it's to the left or upright, there's no activating. Okay. Yes. Action potentials in the auditory nerve. Combining many fibers allow phase locking up to about 5,000 hertz. Many fibers are doing it. Yeah. So then we can see there are two kinds of fibers: high spontaneous rate fibers, and low spontaneous rate fibers. Yeah. Yes, and combining high frequency, high spontaneous rate fibers and low frequencies, low freq- low spontaneous rate fibers, we get many uh, big range. Yes. So a very dynamic range. You can say a high spontaneous rate fiber is activated at a small level of dB, and it increases fast up. The firing rate is increasing fast up to 200 spikes per second, the maximum value. The low spontaneous rate fibers, it needs more level to be activated, is activating slower, uh, but it's the spikes can continue to increase after 100 dBs. So a bigger range there. For a high spontaneous rate fibers is between history is between 20 or 40 to 40 dBs from slow spike firing rate to high spike firing rate. And then we have this neural tuning curves. Maybe I will not talk about it in the exam. Similar tuning curves as similar tuning as mechanically on the basilar membrane. Tuning curves. This frequency response of single auditory nerves. Single auditory nerves. Input many sinusoids at different frequencies, but at a certain place. The minimum sound level needed to elicit a threshold activity. The minimum sound level to elicit threshold activity. Sharp tuning it's shallower on low frequency side. Yeah. So yes, sharp tuning. So that means that you can say, yeah, it's a certain place on the basilar membrane with several frequencies, and a single auditory nerve with several frequencies. Yes, I think it was that. So I will stop here. It's a little bit complicated. I have to practice.